9.5b. Remember, yesterday we talked about sine and cosine, so and ca. The abbreviation for sine is actually sin. Abbreviation for cosine is cos. And the abbreviation for tangent is tan. So, you can only take a trigonometric function of an angle. The trigonometric function is we're dealing with angles. And what is the funny helper words to remember sine, cosine, and tangent? Remember so, ka, and toa. So, ka, toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And toa is opposite over adjacent. So if I picked angle J right here, so sine of J, opposite, which is KL, over hypotenuse, which is JK. My cosine is adjacent, which is JL, over hypotenuse, which is JK. And then my tangent is tangent of J, which is opposite, which is KL, over my adjacent, which is JL. We will be using trig functions to solve for missing side lengths today. First, we set up by we write the correct trig function. Either we want to find sine or cosine or tangent. We don't know which one, but we'll figure it out. We start with the ones you know, the angle you know, and this is always an acute angle. This is the acute and it's given. It's the thing that's given. Then we label the angles that you know with O as an opposite, A as an adjacent, and H as an hypotenuse. And then you choose the correct functions from your letters of so, ka, toa. And then we replace the known angle, measure, and side lengths. And then finally, when we solve, we use algebra, where we cross multiply along with our calculator. So here, let's try some of this out. So first, our known angle is here. This is our known angle. This is my opposite. This is my adjacent. And this is my hypotenuse. So this is OAH. Solve for x. X is O. I am given my hypotenuse, so O and H. And then I'm given this, so we have an O and H. So we want to use sine, because O and H with so. So we want to use sine here with so. So let's set this up. So here, my sine of 26 degrees over 1 must equal x, which is opposite over hypotenuse, x over 14. And we cross multiply using to solve. So then we have x should equal 14 times sine of 26 degrees, which if I plug that into my calculator, it should get about, 6.1. Let's find y. Y is down here. Y is an adjacent, and I'm given my hypotenuse. So I want to use cosine, which is ka, adjacent, and hypotenuse. So let's set this up. We know that my cosine of 26 degrees must, over 1, must equal my adjacent, which is my y, the thing I don't know, over my hypotenuse, which I do know, which is 14. So I can cross multiply. This gives me y equals 14 times the cosine of 26 degrees Plug that into the calculator. It is about 12.6 for my cosine. Let's keep on doing some more examples. So number 2, if I want to solve for A, my A here, first I'm going to look at my angle. My opposite, this is my O. This is my A. My adjacent, which is right next to it, is A. And then my A here is H. I have I want to find A, which is H. I have A, which is A right here. So I want Ka. So we want cosine. So my setup, so cosine of 48 degrees over 1 is the same as cosine is adjacent over hypotenuse, which is 10 over A, cross multiply. So then A times the cosine of 48 must equal 10. Well, then A should equal 10 divided by cosine of 48, because if I divide both sides by cosine of 48, I will get rid of my cosine of 48 on my other side. So plug that into my calculator. A should equal about 14.9, so 14.9. So A is about 14.9. Let's solve for B. B is O. It's my opposite to that angle. I am given my A. I'm given my A. So I want tangent because tangent is TOA. So I really want tangent. So here, my tangent of 48 degrees over 1 must equal opposite, which is B, over adjacent, which is 10. So if I cross multiply, B should equal 10 times tangent of 48, which then that is close to 11.1. Right, number 3, let's try this again. We're given here, so our opposite is there, so this is O, then this has to be adjacent, the other leg, and then this is H as my hypotenuse. I want to solve for U. I am given my hypotenuse, so I'm going to put H down. I already have my H. I want to solve for U, which is my A. So I need Ka for cosine. My setup, so cosine of 65 over 1 must equal adjacent, which is U, over hypotenuse, which is H, 8. Cross multiply, U must equal 8 times cosine of 65, which then if I plug that into my calculator, I should get U is about 3.4. Let's find T. T is O. And I'm given my hypotenuse. That's a given. I know that. So I need SO, or sine. I'll set this up. So sine of 65 over 1 must equal opposite, which is T, over hypotenuse, which is H. Cross multiply. T is then 8 times sine of 65. Plug that into my calculator. T should be about 7.3. Number 4. We have 20. I'm going to do opposite. This is adjacent, and this is hypotenuse. I want R. R is H. I don't know what H is, but I am given my A. So I need Ka. So cosine. I'm dealing with cosine. So cosine of 20 degrees over 1 must equal adjacent, which is 117, divided by hypotenuse, which is R. So here I'm going to cross multiply. So R times cosine of 20 must equal 117. If I divide by cosine of 20 and cosine of 20, R should equal 117 divided by cosine of 20, which gives us R is about, if we punch that into the calculator, 124 degrees, 124.5 degrees, like so. Oh, not degrees, 124.5 distance. Apologize about that. S. S is O, our opposite. We are given our adjacent. So we are dealing with TOA, or our tangent. So I'll set it up. Tangent of 20 degrees over 1 must then equal opposite over adjacent, which is S over 117. We'll cross multiply. S equals 117 times tangent of 20. And plug that into the calculator. S should equal about 42.6 distance.